England. June 14th. 1943. The desperate radio call crackled through static at RAF Wattisham as Lieutenant James Harrington nursed his crippled P-51B Mustang across the English Channel. Fuel pressure dropping, 20 miles from base. His voice, strained but controlled, masked the grim reality. Without long-range capability, another pilot faced certain death over Berlin. Lacking range, American fighters could only escort bombers partway to targets, leaving them vulnerable to Luftwaffe interceptors. In that mission alone, 17 B-17 fell from formation. The P-51 was America's most promising fighter, but a critical flaw in its fuel system, bearings limited range to just 750 miles, not nearly enough for the 650-mile round trip to Berlin and back. The design team had already rejected multiple solutions, declaring the problem unsolvable with current metallurgy. What they couldn't know was that a stubborn machinist from Ohio had already created the answer, only to have his designs thrown into a rejection pile at North American Aviation. His bearing design would eventually save thousands of lives, but first it would need to survive the bureaucracy that buried it. Tommy Mitchell wiped sweat from his brow as he hunched over his workbench at North American Aviation's Columbus plant. Outside, autumn leaves swirled across the parking lot, but inside, the air hung heavy with machine oil and tension. The date was September 17th, 1942, and America's war effort faced a critical problem, one that Tommy believed he could solve. The machinist squinted through his glasses, calloused fingers making minute adjustments to a prototype bearing assembly no larger than a pocket watch. His workspace was cluttered with tools, technical drawings, and failed prototypes, each representing countless hours of aftershift work. Officially, he was just a grade dry machinist, his job to produce parts according to engineering specifications. But Tommy had identified a fatal flaw in the P-51's fuel transfer system bearings that limited its range severely. Mitchell, the sharp voice of Supervisor Wilson, cut through the mechanical hum of the factory floor. "This isn't R.D. Those parts for the wing assembly are due by end of shift." Tommy straightened, concealing his prototype bearing beneath a rag. "Yes, sir." "Almost finished. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you." Wilson lingered, eyes narrowing at Tommy's workspace. "And clean up this mess. This isn't your personal workshop." He gestured dismissively at Tommy's scattered notes. "Leave the engineering to the college boys upstairs. Those college boys, engineers with degrees from MIT and Purdue, had designed a P-51 that performed beautifully in every aspect, except one: range. With standard bearings in the fuel transfer system, the Mustang could fly only 750 miles round trip, far short of the 650 miles needed to escort bombers to Berlin and back. Without fighter escort, bomber losses were catastrophic. As Wilson walked away, Tommy's hand drifted to the prototype under the rag. The bearing looked simple, a polished ring of metal with innovative composite sleeve inserts, but its implications were profound. If it worked, it would solve the fuel system's inefficiency, extending range by reducing friction and preventing the micro cracks that led to premature bearing failure. At home that evening, Tommy's modest Cleveland apartment served as his second workshop. Kitchen table cleared of dinner dishes, he spread out his technical drawings under a single hanging lamp. His wife Eleanor moved quietly around him, used to these evening sessions. "They rejected it again?" she asked, placing a cup of coffee at his elbow. Tommy nodded, frustration evident in the tight line of his mouth. "Fourth time." Wilson wouldn't even look at it, said I should stick to my pay grade. Eleanor touched his shoulder. "They'll see eventually, Tommy. You've always been able to see things they can't." She was referring to more than his mechanical aptitude. Before the war, Tommy had worked at Cleveland Ball Bearing, where his intuitive understanding of metallurgy had earned him respect despite his lack of formal education. But at North American Aviation, credentials mattered more than demonstrated ability. Tommy sipped his coffee, studying the drawings. The problem is in the coefficient of expansion. The standard bearings can't handle the temperature fluctuations at high altitude. They expand, contract, develop microfractures, then fail completely. That's why the fuel transfer system keeps breaking down on long missions. His solution was elegant, a composite bearing with a layered design that accommodated different rates of thermal expansion. It would maintain integrity through extreme temperature variations from ground heat to stratospheric cold. The materials weren't exotic, just cleverly combined and machined to unprecedented tolerances. "I've submitted the design through proper channels 4 times, Tommy said, rubbing his eyes. Each time, rejected without testing. Apparently, a machinist couldn't possibly have solved what their engineers couldn't. The next morning, as Bziebsen mission reports from Germany detailed another day of heavy losses, Tommy made a decision. He would bypass the system entirely. Colonel Robert Thorne leafed through intelligence reports in his office at Wright Field, Ohio. The October 1942 morning was crisp, falling leaves visible through his window. As head of the Army Air Force's Fighter Development Section, the weight of America's air superiority, or lack thereof, rested squarely on his shoulders. A knock at the door interrupted his reading. His secretary entered, apologetic. "Sir, there's a machinist from North American. Says he has something urgent about the P-51 range problem. I tried to redirect him, but he's quite persistent." Thorne Seahead. "Send him in." Tommy entered, cap in hand, a small wooden box tucked under his arm. Despite his civilian status, he stood almost at attention, the discipline of his work evident in his posture. 3 minutes, Mr. Mitchell, sir." "Thomas Mitchell. Thank you for seeing me." Tommy placed the box on Thorne's desk and opened it, revealing the bearing assembly nestled in felt. "This will solve the P-51 range problem." Thorne's expression remained neutral, but his eyes sharpened. He'd seen dozens of proposed solutions, none viable. "That's a bold claim, Mitchell." "Yes, sir. I've been a machinist for 15 years. The bearing failures in the fuel transfer system are caused by thermal expansion disparities. My design accommodates the full range of operational temperatures." Thorne picked up the bearing, turning it in his fingers. Unlike most visitors to his office, Mitchell didn't launch into technical jargon or overblown promises. He simply waited, letting the component speak for itself. "You've tested this?" "Not in aircraft, sir. North American wouldn't authorize it. But I've run bench tests simulating operational conditions. The results are in that folder." Thorne flipped through Tommy's meticulous notes. Despite their lack of formal presentation, the data was compelling. "And North American rejected this?" 4 times, sir. "I'm here because while they're deciding, pilots are dying." Something in Mitchell's direct approach resonated with Thorne. He'd flown in the previous war and recognized the practical mindset of men who worked with machinery daily. Sometimes the most elegant solutions came not from engineering departments, but from those who intimately understood machines through their hands. "Wait outside, Mitchell." When Tommy was gone, Thorne made a call to Major Paul Richardson at the materials testing laboratory. "Paul, I need an emergency evaluation on a component. Today." 3 hours later, Tommy sat across from Thorne again, this time with Richardson present. The Major placed a test report on the desk. "It works," Richardson said simply. "We subjected it to the full temperature range, from desert heat to stratospheric cold. Outperforms the standard bearing by a factor of 3. Friction reduction is remarkable." Thorne studied Tommy. "Why did North American reject this?" Tommy chose his words carefully. "I'm a machinist, sir. No engineering degree. I believe they felt the solution couldn't come from the factory floor." Thorne nodded slowly. "Bureaucracy and pride. Two enemies as dangerous as any we're facing overseas. He made a decision. Major Richardson, prepare authorization for immediate testing in an operational P-51. Priority classification. Mitchell, you're temporarily assigned to right field under civilian contractor status. As Tommy left the office, a weight lifted from his shoulders. For the first time since identifying the problem, he allowed himself to hope. His bearing would be tested not because of who he was, but for what it could do. Right field test facilities hummed with activity as technicians prepared a P-51B for flight testing. Tommy's bearings had been installed in the fuel transfer system overnight, replacing the standard components. The date was October 23, 1942, and a light frost covered the airfield. Captain Michael Donovan, test pilot, listened intently as Tommy explained the bearings' function. Unlike the engineers who had dismissed the machinist, Donovan respected anyone who understood aircraft components. His life depended on such people. So these bearings will maintain integrity throughout the mission profile? Donovan asked, examining the removed standard bearings with their visible stress fractures. Tommy nodded. The composite design handles thermal expansion differentially. The inner sleeve expands at a different rate than the outer race, but the intermediate layer compensates, maintaining optimal clearance throughout the temperature range. Donovan smiled slightly. For just a machinist, you speak engineer pretty well. Had to learn their language to be ignored in it, Tommy replied with a hint of wryness. The test flight was scheduled for a simulated Berlin mission profile, 650 miles, with appropriate altitude changes and combat maneuvers. If Tommy's bearings performed as expected, fuel efficiency would improve by approximately 42%, enabling the full mission range without modifications to fuel tank capacity. As the P-51's Merlin engine roared to life, Tommy felt his heart rate increase. Years of experience had taught him to trust his work, but never had so much depended on a single component. The fighter taxied down the runway, gained speed, and lifted gracefully into the morning sky. Now all Tommy could do was wait. 7 hours later, as afternoon shadows lengthened across right field, the distinctive sound of the Mustang's engine announced Donovan's return. Tommy, Colonel Thorne, and Major Richardson watched as the fighter touched down and taxied toward them. The flight had lasted nearly twice as long as would have been possible with standard bearings. Donovan climbed from the cockpit, flight suit darkened with sweat. He pulled off his helmet, revealing a broad smile. "It works," he said simply. "Fuel efficiency is up dramatically. I flew the full profile with fuel to spare." Engineers immediately began examining the bearings. After disassembly, the results were clear. No significant wear, no thermal stress patterns, no indication of imminent failure. The bearings had performed flawlessly. Colonel Thorne turned to Tommy. "Mr. Mitchell, I believe you've just extended the combat radius of our most promising fighter aircraft. The implications are—" He paused, calculating the strategic impact. Profound. Preparing and narrating this story took us a lot of time. So if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. Within days, Thorne had convened an emergency procurement meeting. Representatives from North American Aviation, the War Production Board, and Army Air Forces Material Command gathered around a conference table at Wright Field. The atmosphere was tense. Accelerating production modifications midstream would create disruption, but the potential strategic advantage couldn't be ignored. Gerald Crawford, North American's chief engineer, examined the test data with a deepening frown. "These results are compelling, but implementing a design change now would disrupt production scheduling. We're already behind on delivery commitments." "And how many aircraft are we losing because they can't reach their targets with escort?" Thorne countered. "Yesterday's raid on the submarine pens at Saint-Nazaire lost 11 bombers after our fighters had to turn back. 11 crews, 110 men. The room fell silent as the human cost settled over them. Tommy, seated at the far end of the table, spoke up. The modification can be implemented with minimal disruption. The bearings are the same dimensions as the originals. No system redesign required. Crawford's eyes narrowed. Mitchell, I should have known. His tone carried months of dismissed suggestions and institutional resistance. This was rejected through proper channels. And yet it works, Thorne interjected. The data is irrefutable. 7-hour flight time, minimal wear pattern, no failure indicators. Major Richardson from materials testing added, "We've completed accelerated life cycle testing. These bearings will last approximately 3 times longer than standard components under identical conditions. Failure rate projection is under null. 3% for a standard 100-hour operational period." The War Production Board representative, a sharp-eyed woman named Margaret Wells, had been silent until now. "What's the materials situation? Any strategic metals acquired?" Tommy shook his head. "No, ma'am. Standard alloys with modified machining processes and tolerances. The innovation is in the design and layering, not exotic materials." Wells made notes. "Production scaling? Any machine shop that can produce the current bearings can produce these with minimal retooling," Tommy replied. "The process requires greater precision, but no new equipment." The meeting continued for hours. Technical objections raised and addressed, production schedules recalculated, implementation strategies developed. Through it all, Tommy answered questions with the quiet confidence of someone who understood his craft completely. By evening, decision had shifted from whether to implement to how quickly it could be done. As the meeting concluded, Crawford approached Tommy. The engineer's expression was complicated, professional pride wrestling with undeniable results. "You should have been more persistent, Mitchell," he said finally. Tommy met his gaze steadily. "I was. 4 submissions, 4 rejections." Crawford nodded slowly. "Then the failure was ours." He extended his hand. "We'll need you to oversee implementation." In January 1943, the first production P-51 Sekunde with Mitchell bearings began rolling off North American's assembly lines. The modification added approximately $94 to the aircraft's $51 cost, a negligible increase for transformative capability. Tommy was transferred to a new role, splitting time between production oversight and continued development. The true test came on der 11. Januar 1943, when 16 P-51Bs escorted bombers to targets near Berlin, the first time American fighters had made the complete journey. All 16 returned. In the months that followed, bomber loss rates dropped dramatically as Mustangs provided protective umbrella all the way to the most distant targets and back. By March, Tommy had been formally recognized with a new position, Special Technical Advisor to the Fighter Development Section. His small office at Wright Field contained a workbench alongside the standard desk, a reminder that hands-on understanding remained his greatest strength. On his wall hung a letter, framed. It was from the commander of the 357th Fighter Group, describing how P-51 Sekunde had driven off German interceptors during a raid on aircraft factories in central Germany. The last line read simply, "Your bearings brought my boys home. Wright Field, Ohio, May 15th, 1943. As the morning sun cast long shadows across the airfield, a gathered crowd of officers, engineers, and production officials watched a formation of P-51B Mustangs take flight. The demonstration wasn't about speed or maneuverability. Every person present already knew the Mustang excelled in both. Today's test measured something more vital: endurance. The fighters climbed in tight formation, their Merlin engines humming with mechanized precision before turning east toward the rising sun. They would fly a plotted course, mimicking the Berlin route, 825 miles out, 825 miles back, with simulated combat maneuvers at the midpoint. In the control tower, Tommy Mitchell stood beside Colonel Thorne, watching through binoculars as the formation grew smaller against the horizon. "Nervous?" Thorne asked, not taking his eyes from the diminishing aircraft. Tommy adjusted his glasses. "They'll make it. The engineering department at North American still has reservations, Crawford particularly. Crawford's worried about his reputation, not the bearings," Tommy replied. "But those pilots don't care who designed what. They just want to come home." 7 hours later, as afternoon shadows stretched across the airfield, the distinctive drone of Merlin engines announced the formation's return. All 8 Mustangs touched down in sequence, taxiing to the apron, where ground crews immediately began examining the fuel systems. Tommy moved among them, checking bearing temperatures, inspecting for wear patterns, and noting fuel consumption figures. Captain Donovan, the lead test pilot, approached Tommy while removing his flight helmet. Sweat had plastered his hair to his forehead, but his expression was triumphant. "Like you said, Mitchell. Not even a hint of trouble." The bearings performed flawlessly through the entire profile. He glanced at his aircraft, where technicians were already opening access panels. "We pushed them hard, too. Rapid altitude changes, sustained high-power settings, the works." The data collection continued for hours. By nightfall, the results were conclusive. The Mitchell bearings had maintained optimal efficiency throughout the mission profile, with minimal wear and no signs of imminent failure. Fuel consumption showed a 38% improvement over standard bearings, enough to make the Berlin run with a tactical reserve for combat. In the debriefing room, engineers, production managers, and military officials reviewed the findings. The atmosphere had shifted from skepticism to cautious optimism. Gerald Crawford from North American Aviation studied the wear pattern photographs with a furrowed brow. "The performance is impressive," he admitted, the words seeming difficult. "But scaling production to meet operational needs will be challenging." Tommy stepped forward. "I've drafted modified machining procedures that use existing equipment. The primary difference is in quality control tolerances and assembly technique, not the manufacturing process itself." He unrolled detailed technical drawings across the table. The precision of the work belied Tommy's lack of formal training. Every dimension, tolerance, and assembly note was meticulously documented in the standardized format used by production engineers. Crawford studied the drawings with growing surprise. "I've been on both sides of technical documentation, sir. Good machinists need good drawings." The meeting continued late into the night, with my production schedules revised, material allocations calculated, and implementation strategies developed. By morning, the decision was unanimous. The Mitchell bearings would be installed in all P-51 Mustangs, with retrofit kits for aircraft already in service. As dawn broke, Tommy stood alone on the airfield, watching mechanics prepare the test aircraft for their return flight to various units. His bearing design, rejected 4 times, dismissed as impossible, was now classified as mission-critical technology. The validation should have felt triumphant, but Tommy felt only quiet relief. The solution had always been there, waiting for someone to see it. Back at North American Aviation's main plant in Inglewood, California, the integration of the Mitchell bearings into production created initial disruption. Assembly line supervisors struggled to implement the tighter tolerances. Quality control rejected nearly 40% of the first production batch. Manufacturing engineers questioned the necessity of such precision for just bearings. Tommy spent 3 weeks on the factory floor, working directly with machinists and supervisors. He demonstrated techniques, adjusted machine settings, and revised inspection procedures. His approach wasn't to lecture but to show, hands guiding hands, practical knowledge transferred through demonstration rather than documentation. By the end of June 1943, production stabilized, reject rates fell below 5%, assembly lines resumed normal pace. The bearings that initially seemed too complex for mass production became routine components, their manufacture refined to predictable precision. In the executive offices above the factory floor, attitudes evolved more slowly. Crawford and his engineering team maintained a professional distance from the machinist's solution, acknowledging its effectiveness while subtly minimizing its ingenuity in official reports. In meetings, they referred to the modified bearing assembly rather than Mitchell bearings, a small linguistic erasure that didn't go unnoticed. During one production review meeting, General James Howard, recently arrived from Washington, cut through the obfuscation. These modified bearings, they're the ones developed by that machinist, correct? Mitchell. Crawford shifted uncomfortably. The basic concept originated from the shop floor, yes. Our engineering department refined and standardized the design for production. The general's eyes narrowed slightly. Interesting. Because I have a report from right field that suggests otherwise. Seems the refinements were minimal at best. He turned to an aide. Find this Mitchell fellow. I want to meet him. Tommy was located in the machine shop, hands black with oil as he demonstrated a finishing technique to a group of newly hired workers. When informed that a general was waiting, he wiped his hands, straightened his work shirt, and followed the aide to the executive conference room. General Howard was a compact man with shrewd eyes and the weathered look of a former pilot. He studied Tommy for a moment before speaking. Mr. Mitchell, I've been reading about your bearings. Impressive work. Thank you, sir. I understand there was some resistance to your innovation. Tommy chose his words carefully, aware of Crawford and other executives present. New ideas often face scrutiny, sir. That's appropriate in aircraft manufacturing. Howard smiled slightly at the diplomatic response. Perhaps, but I've been reviewing bomber loss statistics before and after your bearings went into production. The difference is striking. He slid a folder across the table. 8th Air Force bomber. Losses on deep penetration raids have decreased by 31% since P-51 Sekunde, with your bearings began, providing full mission escort. The room fell silent. Statistics on the war's human cost were rarely discussed so explicitly in production meetings, where aircraft were typically reduced to units, schedules, and specifications. The folder remained open, its columns of numbers representing hundreds of young men who had returned home because fighters could now accompany them all the way to target and back. Howard continued, The War Department is establishing a new technical innovation unit to fast-track critical developments. I want you on it, Mitchell, Crawford interjected. General, Mr. Mitchell lacks the formal qualifications for such a position. Perhaps in an advisory capacity. Save it, Crawford. Howard interrupted. I've seen enough qualified solutions that didn't work. Mitchell's bearings work. That's the only qualification that matters now. The transfer orders came through on der 15. Juli 1943. Tommy was assigned to the newly formed Technical Innovation Unit at Wright Field, with the civilian rank of Senior Technical Specialist, a position typically requiring an engineering degree and years of documented research. His first task, examining other potential applications for his bearing design across aircraft systems. Eleanor Mitchell stood in their small apartment, surrounded by half-packed boxes, watching her husband organize his technical drawings and notes. I still can't believe it, she said. Wright Field, working directly with the design teams. Tommy looked up, a hint of wonder in his expression. Because I made a bearing. Because you didn't give up, Eleanor corrected. 4 rejections, Tommy. Most would have walked away. He nodded, understanding the truth in her words. Persistence had mattered as much as technical insight. The bearing design was clever but not revolutionary. Its true innovation lay in challenging conventional thinking about thermal expansion and material interfaces. Any competent engineer could have developed something similar if they'd approached the problem differently. I keep thinking about those bomber crews, Tommy said quietly, before the escorts could reach Berlin. How many didn't come back because fighters had to? Turn around halfway? Eleanor touched his shoulder. And how many are coming back now because they don't have to face the Luftwaffe alone? At right field, Tommy found himself in a unique position, neither engineer nor machinist in the traditional sense, but a bridge between theoretical design and practical implementation. His office sat between the engineering department and the machine shop, a physical manifestation of his role. The Technical Innovation Unit operated outside normal military hierarchy, focusing on rapid development of critical technologies. Projects that would typically take years moved through development in months. Ideas flowed freely between disciplines, with practical application the only true measure of success. Tommy's bearing design found new applications beyond the P-51 fuel system. Modified versions improved turret rotation mechanisms in B-17 waist gun positions, reducing freezing and jamming at high altitude. Adapted designs enhanced control surface linkages in P-47. Thunderbolts, improving high-speed maneuverability. Each application saved lives in different ways, creating a ripple effect across aircraft types and combat roles. By September 1943, Mitchell's name appeared on 7 technical patents, with his bearing principles becoming standard reference material for military aircraft designers. Engineers who had initially dismissed him now sought his input on thermal expansion problems and material interface challenges. The most significant validation came not from patents or professional recognition, but from a letter that arrived in early October. It was from Captain James Ferguson, a P-51 pilot with the 357th Fighter Group, recently returned from a mission over Germany. "Mr. Mitchell," it began, "you don't know me, but I know your bearings. Yesterday, I escorted bombers to a ball-bearing factory in Schweinfurt. Heavy flak, heavy fighters, lost 2 from our squadron, but we stayed with the bombers all the way there and all the way home. Before your modifications, we would have turned back halfway, leaving those boys on their own. The bombardier on 1 B-17 told me they lost 6 bombers on a previous Schweinfurt raid when they had no escort. Yesterday, with us alongside them the entire route, they lost 17. That's 43 crews. 430 men, who might not have made it home without your bearings keeping our Mustangs in the fight. I thought you should know." Tommy kept the letter in his desk drawer, occasionally rereading it when facing particularly difficult technical challenges. The human impact of engineering decisions, usually abstract in production meetings and design reviews, became concrete through Ferguson's words. Wright Field's testing facilities worked around the clock as the air war intensified. New aircraft designs, weapons systems, and equipment modifications moved through evaluation at unprecedented speed. Tommy's role expanded to include consulting on various thermal management issues across multiple aircraft types. The colonel looked tired, the strain of managing accelerated development programs evident in the lines around his eyes. "Mitchell, we have a situation with the P-29 program." Tommy nodded. The P-29 Superfortress represented the most advanced bomber in the American arsenal, pressurized, heavily armed, with the range to reach Japan from Pacific Island bases. But its development had been plagued by engine fires and reliability issues. "The engines are running too hot," Thorne continued. "Specifically, the bearing assemblies in the supercharger section. We're seeing catastrophic failures in testing. The damn things literally melt." He pushed a folder across his desk. Inside were photographs of failed Wright 1350 engine components, bearing assemblies distorted beyond recognition by extreme heat. The engineers at Wright Aeronautical have tried 3 different redesigns. Nothing works consistently. General Arnold is threatening to cancel the entire program if we can't solve it. Thorne's expression was grim. "We need your perspective on this. It's not exactly the same as your fuel system bearings, but the thermal management principles might apply." Tommy studied the photographs, already considering possible approaches. The P-51's Wright Cyclone engines operated at higher temperatures and pressures than any previous aircraft engine, pushing materials to their limits. Conventional bearing designs simply couldn't handle the thermal stress. I'll need to see the test data and the current bearing specifications. You'll get everything we have. But Mitchell, Thorne leaned forward, we need solutions in weeks, not months. P-51 production is already underway. Every aircraft coming off the line has potentially defective engines. Over the next 3 weeks, Tommy immersed himself in the P-51 engine problem. The supercharger bearings experienced temperatures approaching 900 degrees Fahrenheit during operation, far beyond what conventional bearing alloys could withstand. Engineers had focused on developing more heat-resistant metals, with limited success. Tommy's approach was different. Rather than seeking more durable materials, he redesigned the bearing assembly to manage heat transfer more effectively. His solution incorporated thermal barriers between components, allowing them to operate at different temperatures without transferring destructive heat from one section to another. The prototype bearing assembly, tested in a modified R3350 engine at Wright Field in November 1943, ran for 200 hours without failure, 4 times longer than the best previous design. When disassembled for inspection, the bearings showed minimal wear and no signs of thermal distortion. General Henry Hap Arnold, commanding general of the Army Air Forces, personally reviewed the test results. His approval was immediate and emphatic. Implement Mitchell's design across the P-51 fleet. Priority authorization for all necessary resources. The P-51 bearing modification represented a larger challenge than the P-51 fuel system. Thousands of engines already in production or installed in aircraft would need retrofit kits. Manufacturing facilities already struggling to meet production, quotas would need to incorporate new procedures and specifications. Tommy spent December 1943 traveling between aircraft plants, training production teams, and working with quality control departments. The schedule was grueling: Wichita on Monday, Seattle on Wednesday, back to Wright Field for testing on Friday, then to Connecticut the following week. But with each plant visit, implementation proceeded more smoothly, as lessons learned were incorporated into the process. By January 1944, the first B-29 Secunda with Mitchell's modified engine bearings began flying from airfields in the Mariana Islands, carrying the strategic bombing campaign to the Japanese homeland. Like the P-51 bearings before them, these seemingly small components significantly influenced the war's outcome, not by adding destructive power, but by ensuring aircraft could complete their missions reliably. In February 1944, Tommy was summoned to Washington. The modest machinist who had once been told to stick to his pay grade found himself in the War Department, being introduced to Secretary of War Henry Stimson and a room full of generals and production chiefs. "Mr. Mitchell," Secretary Stimson began, "your contributions to our aircraft systems have had a remarkable impact on combat effectiveness. The P-51 modifications alone have saved hundreds of bomber crews. The P-51 engine improvements are enabling our Pacific strategy." Tommy stood uncomfortably in the spotlight, unaccustomed to such recognition. "Thank you, sir, but I'm just solving problems. The real work is done by the production teams implementing these changes at scale." Stimson smiled slightly. Modesty noted. "Mr. Mitchell, nevertheless, the President has approved the establishment of an expanded Technical Innovation Division, with you as its civilian director. You'll be working directly with aircraft manufacturers to identify and solve critical technical problems across all platforms." The appointment came with a substantial budget, dedicated facilities at Wright Field, and authority to requisition resources across the military-industrial complex. For a former grade dry machinist whose ideas had been repeatedly rejected, the transformation was extraordinary. But Tommy understood it represented not personal validation, but desperately needed institutional change. The manufacturing world was being forced to recognize that innovation could emerge from any level of the organization, that practical knowledge gained through years of hands-on experience. often provided insights theoretical training might miss. Tommy's bearings had saved aircraft, but his example was changing the system itself. Eleanor joined Tommy in Dayton in March 1944, moving into a modest house near Wright Field. Their living room became an unofficial gathering place for a growing team of machinists, technicians, and engineers who shared Tommy's practical approach to problem-solving. On a warm evening in May, as Tommy sat on the porch reviewing technical drawings, a car pulled up in front of the house. A young man in an Army Air Forces uniform climbed out, looking uncertain as he approached. "Mr. Mitchell?" he asked. Tommy nodded. "Lieutenant David Cooper, 357th Fighter Group. I just got back stateside." The pilot seemed nervous. "I wanted to thank you personally. I flew a P-51 with your bearings for 27 missions over Germany. She never let me down." Tommy invited him inside, where Cooper described missions over Berlin, Leipzig, and Munich, 8-hour flights that would have been impossible before the bearing modifications. He spoke of bomber crews waving in gratitude as Mustangs arrived over targets, deep in German territory, of Luftwaffe pilots surprised to find American fighters waiting for them over their own airfields. "The guys wanted me to give you this," Cooper said finally, handing Tommy a small package. Inside was a silver identification bracelet. Engraved on one side were the words, "Mitchell Bearings, the extra 900 miles that brought us home." On the reverse was a list of bomber groups whose aircraft had returned safely under P-51 escort. As Cooper left, Tommy turned the bracelet in his hands, running his fingers over the engraved names. Each represented hundreds of young men who had faced combat with the small advantage his bearings provided. Not enough to guarantee survival, but enough to improve the odds. Eleanor found him still sitting there an hour later, the bracelet on the table before him. "You changed the war," she said quietly. Tommy shook his head. "I just fixed a bearing. That's not what Lieutenant Cooper thinks." She sat beside him. "Sometimes the smallest parts make the biggest difference." Wright Field, July 1944. Thunderstorms rolled across the Ohio landscape as Tommy Mitchell stood at the massive hangar doors, watching rain pound the tarmac. Behind him, a prototype P-51 sat in partial disassembly, its entire fuel system exposed for modification. The newest version of the Mustang promised even greater range and performance, thanks in part to further refinements of Tommy's bearing design. The third-generation bearings reduced friction by an additional 15%, translating to approximately 150 more miles of combat radius, enough to make the difference in the Pacific Theater's vast distances. A young engineer approached, clipboard in hand. "Final test data from the P-47 Newton modifications, Mr. Mitchell," he said, handing over the report. "The bearings are performing beyond specifications." Tommy nodded, scanning the numbers. The P-47, America's other premier fighter, was being adapted for Pacific operations where range was even more critical than over Europe. His bearings were now being implemented across multiple aircraft types, a small component with outsized strategic impact. "Production scaling?" Tommy asked. "Ahead of schedule. The new simplified machining process you developed has increased output by 37% with lower reject rates." Tommy handed the report back with a hint of satisfaction. His team had refined the manufacturing process to the point where even less experienced machinists could produce the precision components reliably. War production had accelerated beyond anyone's early predictions, consuming raw materials and finished parts at rates that stretched American industry to its limits. Every efficiency mattered. "There's something else," the engineer added, hesitation evident in his voice. "General Arnold's office called. They want you in Washington next week. Something about a new priority project." Tommy's expression remained neutral, but inwardly he felt a familiar tension. High-priority projects meant critical problems that had defied conventional solutions, and time was always the enemy. Every day of delay translated to aircraft lost and crews killed. Did they say what it was about? No details, just that it involves the jet program. The mention of jets raised Tommy's eyebrows. America's first jet fighter, the P-51 Shooting Star, was still in early production, plagued by technical challenges and development delays, while Germany already had operational jet fighters in the Me 262, American jets remained primarily experimental. "I'll be on the morning train," Tommy said, turning back to the prototype P-51H. "Let's finish this modification first. Washington, D.C., der 24. Juli 1944. The Pentagon's endless corridors buzzed with activity as Tommy was escorted to a secure conference room deep within the massive building. The walls were lined with technical drawings of aircraft he recognized as early jet designs, the Bell P-59 Aerocomet, the Lockheed P-50, and the several configurations he didn't recognize. General Henry Hap Arnold, commanding general of the Army Air Forces, sat at the head of the table, surrounded by senior officers and engineers. The atmosphere was tense, the faces around the table showing the strain of managing a global air war, while simultaneously racing to develop next-generation technology. "Mitchell." Arnold nodded as Tommy entered. "Thank you for coming on short notice." Tommy took the offered seat, aware that he was the only person in the room without either military rank or advanced academic credentials. Yet the reception was notably different from his early days at North American Aviation. There was no dismissive glance at his lack of qualifications, no questioning of his presence at such a high-level meeting. Arnold wasted no time on pleasantries. "We have a critical situation with the jet program. The Germans have the Me 262 Zoll squadron service. Intelligence estimates they'll have over 500 operational by year's end. Our P-50 development is behind schedule, primarily due to engine reliability issues." He pushed a folder across the table. "The problem is in the main shaft bearings. At maximum power, temperatures exceed 200 degrees Fahrenheit. Standard bearings fail catastrophically after approximately 25 hours of operation. We've lost test pilots." Tommy opened the folder, examining photographs of failed components. The damage pattern was familiar. Thermal expansion leading to microfractures, then complete disintegration under load. But the severity was unlike anything he'd seen in piston engine applications. "We need a solution that can be implemented immediately in production," Arnold continued. "The bearing failures are the primary bottleneck in the P-50 program." Tommy studied the technical specifications silently. The centrifugal jet engine operated at rotational speeds and temperatures far beyond conventional aircraft engines. Every material and design assumption was being pushed beyond established limits. "I understand why you called me," Tommy said finally. "But this is beyond an incremental improvement of existing bearing technology. The thermal conditions exceed what any conventional bearing can handle." A senior officer across the table made a dismissive noise. "That's what our engineering department said. I thought you were brought here precisely because you see solutions others miss." "Cut price." Tommy met the man's gaze calmly. "I'm not saying it can't be solved. I'm saying it requires a fundamentally different approach, not just an improved version of existing designs." He turned to a blank page in his notebook and began sketching rapidly. "The problem isn't just the bearing material, it's the entire thermal management approach. We're trying to make bearings survive heat when we should be focusing on preventing that heat from reaching them in the first place." For the next hour, Tommy outlined a concept for a completely redesigned bearing assembly with integrated cooling channels and thermal barriers. His approach didn't try to create bearings that could withstand impossible temperatures. Instead, it created a system that prevented those temperatures from developing in the critical areas. As he explained the concept, the initial skepticism around the table gradually shifted to focused attention. Engineers began asking technical questions. Materials specialists discussed manufacturing feasibility. Production managers considered implementation timelines. General Arnold listened silently until Tommy finished, then spoke directly. How quickly could this be prototyped? Tommy considered the question carefully. With proper resources, 2 weeks for the first test units. But this isn't something I can develop alone. I'll need a team. Engineers, metallurgists, machinists. You'll have them, Arnold replied without hesitation. I'm establishing a special project office at Wright Field, effective immediately. Full priority, authorization for personnel and materials. He turned to his aide. Draft the orders. Mitchell will have whatever he needs. As the meeting concluded, Arnold held Tommy back while the others filed out. When they were alone, the general spoke candidly. Mitchell, the situation is more urgent than I indicated in there. The Germans are developing jet bombers that could threaten our forces in Europe. If we don't have operational jet fighters by early next year, we could face a technological gap that costs thousands of lives. Tommy nodded, understanding the unspoken message. This wasn't just about winning the war faster, it was about preventing a potential reversal that could extend the conflict and its casualties. I understand, sir. We'll solve it. Arnold studied him for a moment. You know, when they first told me a machinist had solved the P-51 range problem, I was skeptical. Engineers with advanced degrees had been working on it for months without success. But then, I saw the test results. He smiled slightly. Sometimes the most valuable perspective comes from unexpected sources. Tommy returned to Wright Field the following day, where a dedicated facility had already been established for the jet engine bearing project. The team assembled under his direction included engineers from major aircraft manufacturers, metallurgists from research laboratories, and skilled machinists from production facilities. The atmosphere in the project center was electric. The urgency of their task eliminating the usual bureaucratic barriers and professional rivalries. Tommy established a working environment unlike traditional military development programs, where credentials mattered less than contributions, and ideas were evaluated on merit rather than source. A senior engineer from General Electric, Dr. Robert Kaufman, initially approached the project with visible skepticism. Mitchell, he said during an early design meeting, I've been developing turbine components for 15 years. The thermal gradient you're proposing can't be maintained in an operational environment. Instead of dismissing the concern, Tommy invited deeper critique. Show me where it fails, he said, spreading the technical drawings across the table. For the next 3 hours, they worked through the calculations together, Tommy's practical understanding of metal behavior complementing Kaufman's theoretical knowledge. By evening, they had identified critical weaknesses in the initial design and developed solutions that incorporated both perspectives. This pattern repeated across the project, theoretical expertise balanced against practical experience, each strengthening the other. The boundary between engineer and machinist blurred as the team focused solely on solving the problem. The first prototype bearing assemblies were manufactured in 10 days, an extraordinary timeline made possible by the priority status assigned to the project. Testing began immediately, with the components subjected to simulated jet engine conditions in specially designed test rigs. The initial results were promising. Where standard bearings failed after 25 bis 30 hours, the first-generation Mitchell design survived 120 hours before showing significant wear. But Tommy wasn't satisfied. The wear pattern here indicates we're still getting excessive heat transfer through the inner race, he explained, pointing to discoloration patterns on the disassembled components. We need to refine the cooling channel configuration. 3 more iterations followed in rapid succession, each improving on the previous design. By the 4th generation, the bearings exceeded 500 hours in accelerated life testing with minimal wear, more than sufficient for operational requirements. On der 12. September 1944, the first P-51 fighter with Mitchell bearings completed its initial flight test at Muroc Army Airfield in California. The test pilot, Major Richard Stevens, reported smooth engine operation throughout the flight envelope, including sustained high-power settings that had previously caused bearing failures. After completing the test profile, Stevens taxied to the hangar where Tommy waited with the engineering team. The pilot climbed down from the cockpit, removed his helmet, and approached with an expression of contained excitement. "How did it handle?" Tommy asked. Stevens grinned. "Like it was born to fly. No vibration, no temperature fluctuations, just pure power." He extended his hand. "Whatever you did to those bearings, Mitchell, it works." The success of the P-51 bearing design accelerated jet aircraft development across the air forces. By November 1944, all production P-51 incorporated Mitchell bearings as standard equipment. The reliability improvement was so significant that the aircraft's operational deployment schedule was advanced by 3 months. In December, Tommy received a letter from General Arnold, marked personal and confidential. It contained information few outside the highest military circles were privy to, intelligence reports confirming that Germany was rushing development of the Me-162 jet bomber variant, capable of speeds that would make it virtually immune to conventional fighter interception. "Your bearing design has enabled us to accelerate the P-51 program substantially," Arnold wrote. "The first operational squadron will deploy to England in February 1945, months earlier than previously possible. This capability may prove decisive in countering the German jet threat. Few will ever know the role your seemingly small component played in this strategic outcome, but I wanted you to understand its true significance." Tommy shared the letter with Eleanor that evening, sitting at their kitchen table after dinner. She read it silently, then looked up at her husband with quiet pride. "From rejected designs to this," she said softly. "How does it feel?" Tommy considered the question. "Strange," he admitted. 4 years. I couldn't get anyone to look at a simple bearing design. Now generals write me personal letters about strategic outcomes." "Because you were right," Eleanor replied, "and you were persistent enough to prove it." "It wasn't just persistence," Tommy said, thinking of the teams he'd worked with, the engineers who had eventually embraced his ideas, the production workers who had implemented them. "It was finding people willing to judge the work on its merits, not my credentials." In January 1945, Tommy was summoned to the White House. The invitation came without explanation, simply a time, date, and instructions to wear a suit. Eleanor helped him prepare, ensuring his rarely worn formal clothes were properly pressed. "You're not nervous?" she asked, adjusting his tie. "About meeting the president?" "Of course I am." Tommy smiled slightly. "But after facing down Crawford and the engineering department, how much worse can it be?" The Oval Office was smaller than Tommy expected, more intimate than imposing. President Roosevelt, seated behind his desk, appeared frailer than his public images suggested, the toll of leading the nation through global war evident in his features. Yet his eyes remained sharp, his handshake firm. "Mr. Mitchell," Roosevelt began, "I've heard quite a bit about your contributions to our aircraft programs. General Arnold speaks very highly of your work." "Thank you, Mr. President. I'm just part of a larger team." Roosevelt smiled. "Modesty is admirable, but sometimes accuracy matters more. Your bearing designs have extended the range of our fighters, improved the reliability of our bombers, and accelerated our jet program by months. Those aren't small achievements." He lifted a small box from his desk. "The government has created a new civilian honor for exceptional contributions to the war effort, the Medal for Merit. You're among its first recipients." As Roosevelt presented the medal, Tommy thought of the long journey from, in his workbench at North American Aviation, the rejections, the persistence, the eventual validation, not through argument but through demonstrated results. "There's something else," Roosevelt continued. "After the war, we'll need to maintain our technological edge. I'm establishing a presidential commission on technical innovation to ensure that good ideas aren't lost in bureaucracy, regardless of their source. I'd like you to serve as its first chairman. The proposal stunned Tommy. Mr. President, I'm a machinist, not an administrator. Roosevelt chuckled. And that's precisely why you're the right person. You understand both the technical challenges and the institutional barriers that can prevent solutions from being implemented. Your experience bridges worlds that rarely communicate effectively. The meeting concluded with a photographer capturing the medal presentation. As Tommy prepared to leave, Roosevelt offered a final observation. You know, Mitchell, the difference between winning and losing often comes down to small margins. A fighter with slightly greater range, an engine that runs slightly longer before failing. The enemy never sees these advantages coming because they appear insignificant in isolation, but collectively they determine outcomes. He smiled. Never underestimate the strategic impact of solving small problems exceptionally well. In February 1945, the first squadron of P-51 shooting stars arrived in England, their Allison J-33 engines equipped with Mitchell bearings. Though the German jet threat had diminished as Allied forces pushed into Germany, the psychological impact of American jet fighters arriving in theatre was significant. The technological race had ended in effective parity, preventing the asymmetric advantage German planners had counted on. Tommy received a telegram from the squadron commander shortly after their arrival. Aircraft performing flawlessly. Pilots confident, bearings holding, thank you from all of us. As the European war approached its conclusion, Tommy's attention shifted to Pacific operations. The vast distances involved made his range-extending technologies even more critical. Modified P-51 Sekunde with enhanced Mitchell bearings provided escort for B-29 Sekunde over Japan, while bearing improvements in the B-29 Sekunde themselves reduced engine failures on the long overwater missions. In April 1945, Tommy returned to the factory floor at North American Aviation's Columbus plant, not as a grade dry machinist, but as the head of the Technical Innovation Unit. He walked through the machine shop where he had once worked, stopping to observe operators at their stations, asking questions about their work, and listening to their observations. Gerald Crawford, now Vice President of Engineering, joined him during the tour. The engineer's initial skepticism had evolved into genuine respect over the years of collaboration. You could have sent a team, Crawford remarked. Why come yourself? Tommy watched a young machinist making minute adjustments to a complex component. Because the best ideas often start here, he said simply. With the people who work with these parts every day, Crawford nodded slowly. A lesson I've learned rather late in my career, but one I won't forget. As they continued through the plant, Tommy noticed a bulletin board in the brake area covered with photographs, aircraft in flight, ground crews at work, and pilots standing beside their planes. Each image included a handwritten note. What's this? He asked a nearby supervisor. The Mitchell board, the man replied with a hint of pride. Started it about a year ago. Every time we get a letter or photo from a unit using components with your bearings, we put it up. Helps the workers see the impact of what they're building. Tommy moved closer, examining the notes. One from a P-51 pilot described flying cover for bombers all the way to Berlin and back. Another from a B-29 flight engineer detailed how improved engine reliability had saved his aircraft when 2 engines were damaged by flak over Japan. A third, from a maintenance chief, explained how reduced bearing failures had kept more aircraft operational during critical campaigns. The human consequences of engineering decisions, usually abstract in technical discussions, became vividly real through these first-hand accounts. Each note represented lives protected, missions completed, and strategic objectives achieved, all influenced by components that most people would never see or understand. Crawford stood silently beside Tommy, reading the notes. I've spent 30 years designing aircraft, he said finally. But I've never had this kind of direct connection to the people using what we build. That's the gap we need to close, Tommy replied. between the engineers, the production floor, and the end users. When information flows freely between all three, we get better solutions faster. In May 1945, as victory in Europe was announced, Tommy stood with Eleanor in their backyard in Dayton, listening to Roosevelt's successor, President Truman, address the nation by radio. The European war was over, but the Pacific conflict continued. "What happens next?" Eleanor asked. "After Japan surrenders?" Tommy considered the question. The Presidential Commission on Technical Innovation would begin its work, identifying systemic barriers to technical problem-solving across industries and government. His bearing designs would transition to civilian applications, improving commercial aircraft safety and efficiency. The lessons learned about integrating practical knowledge with theoretical expertise would influence post-war industrial development. "We keep solving problems," he said simply, "but hopefully for better purposes than war." In July 1945, Tommy received a visitor at Wright Field, a young Army Air Forces pilot named Chuck Yeager, recently assigned to a new high-speed research program. Yeager began, his West Virginia accent distinctive. "They tell me you're the man to talk to about bearing problems at extreme conditions." "Depends on the application," Tommy replied, curious about the unannounced visit. Yeager glanced around to ensure they were alone, then lowered his voice. "We're planning to exceed the sound barrier. The control surface bearings experience severe temperature fluctuations during transonic flight. Standard components are failing during simulations." Tommy nodded slowly, understanding the significance. No aircraft had yet broken the sound barrier. It represented the next great frontier in aviation, with unknown challenges and risks. "Come to my office," he said. "Let's discuss what you're seeing." As they walked across the airfield, Tommy reflected on how far things had come since that day at North American Aviation, when Supervisor Wilson had told him to stick to his pay grade. The journey from rejected designs to strategic impact had transformed not just his own life, but the institutional approach to innovation itself. His bearings had extended the P-51 range from 750 to 650 miles, enabling fighter escorts to reach Berlin and beyond. Modified versions had improved B-17 turret reliability, enhanced B-29 engine performance, and accelerated P-80 jet fighter development. Each application saved lives in different ways, creating a ripple effect across aircraft types and combat roles. But perhaps the most significant change was in how ideas were evaluated, increasingly on their merit rather than their source. The war had forced institutional hierarchies to bend when results demanded it, creating pathways for practical innovation that peacetime bureaucracy might have blocked. As Tommy began discussing Yeager's supersonic control surface challenges, he recognized that the pattern was continuing. The boundaries between machinist and engineer, between practical and theoretical knowledge, were dissolving, in favor of collaborative problem-solving focused solely on results. The bearing that had been rejected 4 times had done more than extend aircraft range. It had demonstrated that innovation could emerge from any level of an organization, that practical insights often complemented theoretical knowledge, and that the most effective solutions came from environments where ideas flowed freely across professional boundaries. In the end, Tommy Mitchell's legacy wasn't measured in patents or medals, but in aircraft that returned safely, in crews who survived because fighters could escort them all the way to target and back, and in an institutional approach to innovation that valued results over credentials. From a rejected bearing design to the foundation of America's post-war technological edge, his journey embodied the principle that would drive American innovation for decades to come. Good ideas can come from anywhere, and the best solutions emerge when everyone has a voice at the table. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.